everyone. My name is Thora Broyles, and I live here in West Plains, Missouri, where I work and teach at a college called Missouri State University West Plains. We are a two-year branch of a four-year college in Springfield called Missouri State University Springfield. And what we do is we have a few four-year programs, mostly two-year programs, and we teach a lot of the lower level math and sometimes a little bit higher. We teach through Calculus 3 here. A little bit about myself. I'm a couple years from retirement, almost there, 68 and a half, so I could retire if I wanted to, but I'm not ready for it. So anyway, I run and operate the Math and Science Tutoring Center, as well as teach mathematics here at this college. So I keep a pretty busy life, and I love it. I love being busy. I love watching students succeed. So that's what I'm all about, and I really enjoy it. Spent 23 years in West Africa, so that tells you a little bit about myself. So now let's get involved. I chose to do question number 2. I also did question number 1, but as I tried to make a video of it, I realized it was extremely boring because you spent most of your time just working through the steps of doing elementary row operations on an augmented matrix. And so I decided to do number 2 because there was a lot more to that one. So first of all, as you read number 2 on the questions, you realize that there's a lot of information that it would be very helpful to get it recorded and figure out what's going on. So first of all, as we looked at a large apartment building, we looked at what was going to happen. They had 3 different floor plans for each floor. Plan A had 3 3-bedroom apartments, 7 2-bedroom apartments, and 8 1-bedroom apartments on the floor. Plan B had 4 3-bedroom apartments and 4 2-bedroom apartments and 8 1-bedroom apartments on the floor. Plan C had 5 3-bedroom apartments, 3 2-bedroom apartments, and 9 1-bedroom apartments. So that's some of the basic information that we needed to work with. And then X sub 1 represents the number of floors of Plan A, X sub 2 represents the number of floors of Plan B, and X sub 3 represents the number of floors of Plan C, and vector T is the total number of apartments. And it will be expressed as T1, T2, and T3. So there's your basic information that we're going to use as we work our way through this problem. Now, Part A said to write a vector equation using the information that was given. And so my first vector is A, which is expressed as 3 3-bedroom, 7 2-bedroom, and 8 1-bedroom apartments. Vector B is 4 3-bedroom apartments, 4 2-bedroom, and 8 1-bedroom. And vector C is 5 3-bedroom, 3 2-bedroom, and 9 1-bedroom apartments. So there's your 3 vectors. And now X sub 1 represents the number of floors of Plan A, X sub 2 represents the number of floors of Plan B, and X sub 3 represents the number of floors of Plan C, producing our vector T, which is T1, T2, and T3. So there is your vector equation written as a linear combination. You will have X sub 1 times vector A plus X sub 2 times vector B plus X sub 3 times vector C, and it's equal to vector T. So there's your basic foundation of the information that we need. Now, we'll move on to part B. I put all of this on paper because I got tired of trying to write all of the reduced row reduction stuff. It was easier to put it this way, so that's why I did it this way. So let's get another paper up. Part B of this problem requests that you turn and you convert your vector equation to a matrix equation. So that is your next step of this process. Okay, we'll put this one down. So there we have the other one. So as we convert to a matrix equation, we take the three vertical vectors from here, 1, 2, 3, and we put them in the vertical here. For each one of those, x1, x2, x3 is equal to t1, t2, t3. And I wrote here information to keep us straight on what's going on. Row 1 has your 3-bedroom units, row 2 has your 2-bedroom units, and row 3 has your 1-bedroom units. And it's important to keep that information straight as we're going through. So now next is part C. And part C says we're going to do a transition there of R3 to R3. And what we're going to be transitioning is the total number of floors in each plan to the total number of units by body type, by unit type, okay? So, as we go with the rest of that for this C, here's the continuation of part C. Okay, so we have a continuation, 3x1 plus 4x2 plus 5x3. In other words, a multiplication of this times this. And then 7x1 plus 4x2 plus 3x3, the multiplication of this row times this column. 8x1 plus 8x2 plus 9x3, the multiplication of this row with this column, and that's equal to our T1, T2, and T3. Okay, so there we have it. And again, what's going on here? Row 1 is going to be your units for your 3-bedroom units. Row 2 is your 2-bedroom units, and row 3 is your 1-bedroom units. And now D says, what if we assigned a value for x1, x2, and x3? So that's what we did here. x1 is 3, x2 is 2, and x3 is 1. So what is the total number of units by type is what they're asking. So 3 times 3 plus 4 times 2 plus 5 times 1 is equal to 9 plus 8 plus 5, which is 22 3-bedroom units. 7 times 3 plus 4 times 2 plus 3 times 1 is equal to 21 plus 8 plus 3, which is 32 2-bedroom units. 8 times 3 plus 8 times 2 plus 9 times 1 is equal to 16 plus 9, 49 1-bedroom units. So you can see we get the number of units by putting in a substitution for x1, x2, and x3. And through that, we find the total number of each type of unit. So now, our next step, our E, is the long step. And E says, is it possible to have 66 units of T1, 74 units of T1 would be my T1 has the 3-bedroom units. Okay, so T1 would be 66, T2 would be what they give for that, and I'll get the next paper up and so on. So we're going to now see what is possible for a very specific number of units of each type that they requested, and we will find out how many floors, if it's possible, how many floors of each unit type must be built of each plan in order to produce that. So we'll look at how that comes out. here it is. Is it possible to have 66 units of T1, 74 units of T2, and 136 units of T3? In other words, is this going to be possible? Can we do that? Will we be able to build it? And as we're going through this, we have to think of certain parameters. You can't have part of a floor. You can't have part of an apartment. You can't have a negative number of floors. So there's certain things that we have to keep in mind when we get to the end of this. And it will tell us how many possibilities there are to do this. Okay, so first of all, we're going to put it into an augmented matrix. Then I'm going to take that augmented matrix and I'm going to do row 2 is going to be replaced by a -7 times row 1 plus 3 times row 2. And then row 3 is going to be replaced by -8 row 1 plus 3 row 3. And that is going to give me, this one stays the same. Row 2 is going to have a 0, -16 and -26 and -240. Row 3 is going to have a 0 with a -8, -13 and -120. I have checked these over and over and over because I found myself making a lot of mistakes. And when you make mistakes, you don't get good answers. So anyhow, so then our next series is row 3. We are going to do -1/2 of row 2 plus row 3 is going to replace row 3. So when we do that, we end up with 3, 4, 5, 66, 0, -16, -26, and -240, and 0, 0, 0, 0. So my bottom row is all zeros, which is indicative that you have a free variable, and on top of that, you have a possibility of infinite number of solutions. But remember those parameters that we mentioned earlier. Those parameters are going to either permit us to have many, or maybe even only one solution, or no solutions. So we need to keep that in mind. So the next thing we're going to do is we're going to take row 1, multiply, and we're going to multiply 1/4 times row 2 plus row 1. And that is going to give us 3, 0, -3/2 and 6, and then 0, -16, -26, -240. So that didn't change, and the bottom row doesn't change either. Our next step is going to take and do 1/3 of row 1 and -1/16 of row 2 in order to continue on with the reduced row echelon matrix. Okay, so as we complete our row echelon matrix, reduced row echelon, 1, 0, -1/2, 2, because we multiplied this by 1/3, and we ended up with this. And now 0, 1, 13/8, and 15. Again, we multiplied this by -1/16, and we ended up with that, and our 0 row is still the same. So now we're at the reduced echelon, and we can now take that and illustrate each one of the variables in terms of the others. So x sub 1 minus 1/2 x sub 3 equals 2. X sub 2 plus 13/8 x3 is equal to 15, and 0 equals 0. X sub 3 is your free variable. Moving on. X sub 1 is equal to 1/2 x sub 3 plus 2. X sub 2 is equal to -13/8 x sub 3 plus 15, and x sub 3 is your free variable. So now we need to analyze what we're seeing here. There's some interesting things going on. First of all, I notice that I've got a negative number here. That negative number is going to influence the final analysis here. I also have an 8 and a 2 in my denominator. So if I want to eliminate denominators, since I cannot have part and an apartment, I'm going to have to choose values for x3 that will eliminate denominators, turning those into integers. And so therefore, the first number I would choose for my x sub 3 for my free variable would be 8, because that's the smallest positive value I can choose that will eliminate my eliminate what's going on with the denominators. So that will be the first choice that I make for my x sub 3 to see if I actually have any solution or not. Okay, so let's look at that. Do we have a solution? That is our big question right now. Do we actually have a solution? Well, let's see. We're going to move this up so we can get to the other page. And here's the next one. Okay. What if I say my x sub 3 is equal to 8? Well, x sub 2 is negative 13 over 8 times 8 plus 15, which is a negative 13 plus 15, which is 2. So I come out positive, which is good. We have to have a positive. So I have 8 floors of plan C, I think it is. I have to go back to my first page here. Yeah. 8 floors of plan C. I have 2 floors of plan B. And then 1/2 times 8 plus 2 is 4 plus 2, giving me 6. So I have 6 floors of plan A, because x sub 1 is plan A, plan B, plan C. So 6, 2, and 8, giving me a total of 16 floors in the building. How many rooms? Well, 3 times 6 plus 4 times 2 plus 5 times 8 is equal to 66. 7 times 6 plus 4 times 2 plus 3 times 8 is equal to 74. 8 times 6 plus 8 times 2 plus 9 times 8 is 136. So we have just checked it. The numbers we chose for the floors gave us the right number for each type of unit, making a total of 16 floors and 276 units. The last question we need to answer is this the only solution? Or is there more than one solution? Again, we want to eliminate denominators. And so our next possible solution would be 16. If x sub 3 was 16, because 16 is a multiple of your 8 and a multiple of your 2. So what happens if we choose that number? Well, let's see what happens. Okay, so what happens if we choose that? X sub 3 is 16. What's going to happen? X sub 2 is negative 13 eighths times 16 plus 15, which is a negative 26 plus 15, which gives you a negative 11. Anything larger than this is just going to make this negative number become larger and larger. And then, of course, the other two will get larger and larger positive. But that's a problem. You cannot have a negative number of floors. And so, therefore, This is simply not possible because you can't have that negative number of floors. Therefore, this is not a possible solution, and the only possible solution is this one right here. 6 floors of Plan A, 2 floors of Plan B, 8 floors of Plan C, producing 276 units that can be rented out in this apartment complex. Okay, so as we've done this, we looked at various parameters that were required in order to produce a logical solution. You can't have negative number of floors, you can't have partial apartments or partial floors. So therefore you have to stay with integers, and if you have fractions, you have to eliminate those fractions by choosing multiples of the denominator. And so that helps to eliminate fractions, and you end up with only one possible solution to this problem. And that solution is Plan A has 6 floors, Plan B has 2 floors, Plan C has 8 floors, for a total of 66 units, because that's what they wanted, of Plan 3 bedroom, 74 2 bedroom, 136 1 bedroom, making 16 floor building with 276 units. So that is the answer to problem number 2, question number 2 for this video teaching. Okay, we'll see you. Have fun.